So what we're going to talk about today are various methods for helping us remember the unit circle. And in this particular pattern, what we're looking at is just the first quadrant. Because remember, all of these values repeat throughout the unit circle. We just have to change the signs. So if we know the first quadrant patterns, then we can hopefully get the rest of the quadrant patterns. And down here below this partial unit circle, it says cosine has 4, 3, 2, 1, 0 as the numerator in the first quadrant. And they're all under a square root. And sine has 0, 1, 2, 3, 4 as the numerator in the first quadrant, all under a square root. And to remember which one starts at 4, well, cosine comes before sine in the alphabet, so we're going to start here. And once again, cosine is going to be the x value of the ordered pair, but as we start this here, this is going to be square root of 4. And then it's going to be square root of 3, square root of 2, square root of 1, square root of 0. 4, 3, 2, 1, 0. But as we talked about with our hand trick that doesn't show up on the video, all of these values have a denominator of 2. Now sine, like I said, we did cosine 4, 3, 2, 1, 0. Sine goes in the other order, all underneath the square root. So we're going to start at 0, square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. There's our 0, 1, 2, 3, 4. We just put them under square roots. They're in the second part of the ordered pair because the second value in the ordered pair is the sine value. And once again, these are all divided by 2. If you look at a filled-in unit circle, our denominators are 2. So there's the ordered pairs, and I didn't put them in ordered pair form yet. But what happens is we can simplify these values, and when we simplify these values, they will give us the ordered pairs on the unit circle. Square root of 4 is 2. And 2 divided by 2 is 1. Square root of 0 is 0. 0 divided by 2 is 0. Square root of 3 over 2 we can't simplify. But the square root of 1 we can simplify. Square root of 1 is simply 1. Our next one we can't simplify anymore. It's the square root of 2 divided by 2, the square root of 2 divided by 2. In our next value, the square root of 1/2, square root of 1 divided by 2, and the square root of 3 divided by 2. The square root of 1 is 1, and we can't simplify the square root of 3 over 2. And then we've already seen these values in our last one on this quadrantal. Square root of 0 is 0, divided by 2, which is still 0. Square root of 4 is 2, and 2 divided by 2 is 1. Again, another little trick to help us remember the unit circle. But what we also need here when we fill this in is, let's fill in the radians for a little bit more practice. Here's 0 radians. Then this is pi over 6, pi over 4, pi over 3, and pi over 2. Yeah. As we look at our second little technique down here, There is a mnemonic. A mnemonic means memory aid to help us remember the signs. Because if we know that value in the first quadrant, like we just talked about, then all that's changing pretty much are the signs on the terms, on the order pairs. And the mnemonic is all students take calculus. Not necessarily true, but what it means is in quadrant 1, all of the trig values are positive. Sine, cosine, tangent, cotangent, secant, cosecant, some other ones that we haven't talked about yet. In the second quadrant, S. Students starts with S. Sine starts with S. Sine is going to be the positive value in the second quadrant. And remember that sine is a Y value in our order pair. So it's going to be positive. In our third quadrant, for all students take starts with T and tangent starts with T. Our third quadrant is going to mean that the function that's positive is going to be the tangent, which we haven't talked about yet, but that's coming soon. And in our fourth quadrant, all students take calculus. Calculus starts with C and cosine starts with C. Cosine will be a positive value. Cosine is the X value. All students take calculus. A little technique to help us remember where the different functions are, positive or negative. As we flip the page over, what we have on the back here is a couple other ways, or a way to help us with the radian value on the unit circle. And we have this circle completed here. But what happens in the first quadrant is that the numerator is always pi. So pi over 6, pi over 4, pi over 3. It's not the best way, but I kind of look at it as 6, 4, 3, 2. It descends. It gets smaller. Once we know that, then in the second quadrant, the numerator is always 1 less than the denominator, times pi. So it's 2 pi over 3. 2 is 1 less than 3. 3 pi over 4. 3 is 1 less than 4. 5 pi over 6. 5 is 1 less than 6. Then we get over here, half a circle, which is the pi. In the third quadrant, the numerator is always 1 more than the denominator, times pi. So 7 pi over 6, 7 is 1 more than 6. 5 pi over 4, 5 is 1 more than 4. 4 pi over 3, 4 is 1 more than 3. I hope I said that right on the 5 pi over 4. 5 is 1 more than 4. Then in the last quadrant, the numerator is 1 less than twice the denominator, times pi. 3 times 2 is 6, minus 1 is 5. 4 times 2 is 8, minus 1 is 7. 6 times 2 is 12, minus 1 is 11. And then finally, when we finish, we've gone full circle, which is the 2 pi. So one more thing that Mrs. Cross was alluding to here, and I tried to get around and help some people last week when we were looking at our quiz for reference angles when it comes to radians. And once again, when we look back at this circle, what I want to point out to you is that pi over 6 and 5 pi over 6 and 7 pi over 6 and 11 pi over 6 are all related. And when you're looking at a reference angle is a positive acute angle. The positive acute angle is pi over 6. Same thing. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Those 4 are all related. They're all divided by 4. Their reference angle, a positive acute angle, is pi over 4. Every single time. And the same thing with the pi over 3. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Those are all related. And the reference angle for any value over 3 is pi over 3. Which I think I just gave away here, because as I look at that table here, the value of the denominator, pi over 6, I don't know what to say for this one. Pi over 6 is 30 degrees, pi over 4 is 45 degrees, pi over 3 is 60 degrees. But really, when I think of the unit circle, I'm always thinking of radians. So where I really was here is that 5 pi over 6 and 7 pi over 6 and 11 pi over 6, because they're all divided by 6, the reference is pi over 6. And even if we picked like 50 pi over 6, the reference angle would still be pi over 6. 3 pi over 4, 5 pi over 4, 7 pi over 4, they relate back to pi over 4. And finally, 2 pi over 3, 4 pi over 3, and 5 pi over 3 relate back to pi over 3. What are you doing? Never mind.